For question letter B, it might be helpful to go back to our notes because question letter B is asking about a percentage. Specifically, what percentage of students lose eagerness each day? Now, because it says the word percentage, it may be helpful again to think back to where we've done percent questions in this packet before. And if you look back at the lesson that starts on page 10, which was all about percent multipliers, that was where we did a whole lot of talking about how to get a percentage, and then on page 11, how to start taking some shortcuts with percentages. So on page 11, when I was making these videos, I remember writing down some notes that you might have taken yourself about how a percent multiplier happens. A percent multiplier comes from taking 100% plus or minus whatever the percentage is. And the plus or the minus depends on whether the percentage is an increasing or a decreasing percentage. So if we think about it logically, this 100% plus or minus the percentage thing, that's supposed to help us get a multiplier. And if we think about the question that we have the multiplier. The multiplier is 0.88. So in theory, somebody must have done this process. They must have done 100% plus or minus whatever the percentage was, and they must have gotten an answer that they converted to a decimal of 0.88. So the question is, if we went backwards, what was the original percentage that we started with? We don't know that. So let's think about this logically, and let's see if we can maybe retrace the logic so that we could figure out where the 0.88 came from. 0.88 had to come from converting some percentage. So if I think about converting a percentage, usually, and again I'm going back to my notes on page 11 here, usually we take the number and move the decimal 2 places to the left, and that gives us the decimal that we always see in the equation. So like 0.90, for example, came from 90% and moving 2 places to the left. So if in this question I have kind of the opposite situation, I have the result of moving 2 places to the left, logically then I can move 2 places to the right, and that tells me I must have had 88%. That must have been the percentage that I was converting if I got 0.88 as my decimal, as my equation number. But then I have to remember, that's not the percentage of increase or decrease. That was the result of the 100% plus or minus whatever the percentage of increase or decrease was. So now it's almost like I have a bit of an equation to solve. 100 plus or minus something should have given me an answer of 88. Now let's think logically. If 100% turned into 88%, plus doesn't really make sense. So I'm going to erase the plus or minus because that doesn't seem like it makes sense here. It must have been a minus situation. 100% minus something would be down to 88. So that definitely makes sense. Now the question is, what could we have been subtracting? You could do a little bit of algebra if you want to. 100 minus some percentage would give you an answer of 88, and you can solve for the percentage if you want to. Or you can use common sense. Whatever works best for you is fine. But if we do a little bit of algebra, we could add the p to the other side. So 100 equals 88 plus. P stands for percent in this case. And if I subtract 88, which some of you might already have done in your heads, you would figure out that the percentage must have been 12%. 100% minus 12% gives you 88%. And since we knew for sure that 88% was the multiplier, they gave us that, we can now be certain that 12% of students must have been losing or decreasing in eagerness each day. So now that I know that I have a 12% decrease, that multiplier makes sense. Because I would have done 100% minus 12%, that would have been 88%, and then I would have converted that to a decimal, and yes, I would have gotten 0.88. So it does seem like it's logical. Now, for letter C, it says, how many eager students will be at school after 30 days? Now, days doesn't have anything to do with the percentage. So now I want to look back at my equation and ask myself, well, which part has to do with days? The initial value is 2866. That's the number of students. The 0.88 has to do with my percentage, so the days must be the n. That's the number of days that we have to deal with. So if this is telling me 30 days, then logically it seems like I can plug 30 into the equation and I don't have to do any real actual mathematics other than perhaps grab my calculator, because that looks like a complicated calculation that I'm not sure that I can do in my head. So any sort of calculator will do, fancy or otherwise. Even a phone calculator will do the trick. We can do 0.88 to the power of 30, because remember PEMDAS says exponent first. Then we would multiply by 2866, and that gives us 61.909. But remember, we're talking about a number of students, so having 0.9 doesn't really make sense in this context. We would say we have approximately 61 students. And that does make sense, because if things are decreasing and they're started out with 2,800 students, and if it was decreasing over time, I'm expecting that after 30 days, I'm going to have a much smaller answer. And so 61 kind of makes sense. It's always a good idea after you get an answer to ask yourself, does that make sense with the situation? If it doesn't, then usually that tips you off, like maybe there's a typo somewhere or something you need to fix. Now that you've seen this, hopefully you can feel confident that you can deal with any percentage question. We've seen lots of percentage questions, and this was just another example. Question number 5 is not a percentage question at all. So question number 5 in the last series of videos is basically going to be a question that you can challenge yourself with if you feel like you remember how to do some of these from past lessons, or you can watch the video and I'll walk you through. But it is different than question number 4 and even question number 3. So it's worth being aware of that difference before you go into it.